All right, welcome everybody, and thank you for joining us today. My name is Kevin Thorley. I'm the Enterprise Architect at Dealer.com. Dealer.com is a member of the Cox Automotive family. We are focused on providing digital marketing solutions to auto dealerships in the United States and Canada. We provide a website platform for the dealership websites. We also provide a number of advertising offerings for the dealerships. And I'm joined here by Justin Kaufman.
I'm Justin Kaufman. I'm a director of software engineering at Autotrader.com, part of the Cox Automotive family. Been with the company about 12 years. Had the great pleasure to, continue to help people find and shop for cars. I've also had a lot of experience helping, do some technology, infrastructure, application stack changes to Autotrader.com over the years. So happy and excited to be doing it one more time here with AWS and talk a little bit about that with you all today.
So we're here to talk to you about what has been about a 2-year migration to this point. About 2 years ago, we really started to look at what it would take to move Cox Automotive's workloads, primarily software as a service workloads, into AWS. And we're going to talk about some of the things we've learned, some of the technical learnings, some of the organizational learnings. We've got 3 main sections. We'll talk about organizational change management. We'll talk through engineering enablement, how we help the teams get up to speed and really start executing quickly. And then we'll also talk about some of the architectural and technical patterns that we've kind of uncovered or Amazon has helped us to uncover along the way. And then we'll go through a couple case studies of specific migrations and work that we've done both at Dealer.com and at Autotrader.
So a little bit more about who Cox Auto is. It's a relatively new name in the industry. We formed a few years ago, bringing together a lot of different companies, a lot of different brands. Some of these may be fairly familiar to you, some maybe less so, more kind of back office in the industry. But basically we focus on providing products and services to car sellers, car shoppers. We fit into the wholesale space, retail, media, even some financing as well. So again, trying to really cover the broad spectrum of helping move cars and help people find cars. We are consistent of over 25 different brands, and we have advertising reach of over 73% of all car shoppers in the industry.
So there's a lot of reasons we might adopt a public cloud, why we might adopt Amazon. And when it comes down to it, when you look at all those reasons, the thing that we're really focused on is transforming the way that we can build, deploy, and operate our products, and do so while we continue to provide excellent product and excellent experience to our clients. You've all heard the phrase, reducing undifferentiated heavy lifting. And that's been around for a while. That's a big part of it, but for us it's also, if a dealer were to come in, if one of our clients were to come in and talk to our teams, would they be excited about the work the team is doing, or would the team be excited about the work they're doing, right? And we'll never get to a point where we say 100% of the effort that we're doing is directly to support client value, but we want to move the needle further in that direction. And we believe that Amazon helps us there in terms of speed to market, reducing the undifferentiated heavy lifting, and just giving us a suite of technologies that we don't need to build ourselves, and we have experts helping to operate.
So talk a little bit about the size and the scope of the challenge and the opportunity we're faced with here. Just want to throw some numbers at you, let you know kind of what we're talking about as we talk through our journey and our experiences and kind of where we came to the recommendations that we have today. We're currently running in over 45 different data centers around the world. That's supporting the work of over 2,000 different engineers. I think somewhere a little over 250 different individual development teams. Again, I mentioned we have 27 brands. And these teams are really located all around the world. So we have a lot of geographical diversity. Most of our concentration, we have large engineering teams in California, Texas, Georgia, Vermont, New York, all over the United States, many other locations as well. And it's not just geographical diversity that we're trying to coordinate and get everyone working together as we scale up our enterprise. We have a lot of technical diversity too. So we're trying to migrate and help coordinate movement up to AWS or new development on AWS with a variety of languages written in anything from Ruby, .NET, Java, JavaScript, Python, you name it, we probably have it somewhere in our enterprise. And we're really looking to migrate a lot of existing applications off of anything from a Red Hat virtual machine to an AS400. So again, a lot of diversity here. And it's not just the technical and geographical diversity that's the real challenge and provides the most opportunity. It's really trying to get us to really leverage all the unique cultures, unique skills that we have across our enterprise, get everyone talking a little bit more, working a lot more together. And it's really challenging there if you think about the different types of operational models a lot of organizations have. We have certain teams that still have very independent, large operational teams separate from the development teams. We've got other places on the opposite end of the spectrum that some of our teams are very close-knit, DevOpsy, two-pizza teams that are doing more of a modern practice. So really trying to leverage the skills and the experience and expertise across all those teams is really the goal we're going after here.
So, for the past 2 years, we've been answering a lot of questions. And in the beginning, some of them were the very obvious questions. Justin mentioned that we have teams that do operations today. We run 45-ish data centers, or we have presences in that many data centers. So initially, we talked about public cloud versus private cloud, and that was a big initial question. And then once we kind of started going in the direction of public cloud, well, which vendor do we use? And you won't be surprised. The different teams had different opinions based on maybe what tech stack they were most familiar with. Once we get to the point of choosing AWS, we still had decisions. Do we go IaaS? Do we build a platform on top of EC2? Do we take a fully baked PaaS approach? Do we lift and shift? Justin mentioned 27 brands, thousands of applications, right? We've got very service-based applications. We've got huge monoliths, right? So we have a lot of diversity that needs to be taken into account there. Can we do it in a secure manner? The security team, not surprisingly, wanted to know if it would be as secure in the cloud as we are in our on-prem data centers. And what will it cost? And these are only a very small number of the questions we were faced with. What we wanted to do was find a model that we could use to help answer those questions. We didn't want to be answering each one from first principles. So we have a number of engineering tenets, and these predate the AWS migration effort. But when we answer those questions, we really try and come back to these tenets. We won't outsource our competitive advantages or our core competencies. We believe that we do a really good job of providing solutions in the automotive industry. We believe we're one of the best at doing that. We also believe we're very well positioned based on the companies that are part of the Cox Automotive family, the data that we have to do that. So that's something we focus on. We want to also focus our efforts on solving our clients' problems. There's many problems out there to solve. A lot of them are really fun. We want to focus on solving our clients' problems. And finally, we want to make it easy to do the right thing. We have a lot of teams, a lot of technical diversity, a lot of cultural diversity amongst those teams. We want teams to do the right thing because it's easy. We want the teams to do the right thing because it's getting their product out to their clients faster. We want them focused on solving the problems that they are really good at solving. And to do that, we need to make decisions that make it easy for them to do those things.
So as we started our journey, we quickly realized, and maybe it was fairly obvious, but it took a while for it to sink in. And a lot of the time and effort that Kevin, myself, and many others in our organization spent a lot of time doing is really understanding that this is really an organizational change. It's an effort in leading change. And so a lot of the work that we spent, and again, continue to spend, is really getting people to understand that this is a large, company-wide initiative. Everyone seeks to benefit from it, and it's really critical to make sure that you're putting forth a vision for your company, for your enterprise, for your teams that's really meaningful to each individual, each different team. There's a lot of different engineers that might be really excited and already willing to jump in and see all the shiny new toys that they want to play with. It's really important to just make sure that you're focusing on the bigger, broader organizational goals that we're going after. And so with that, it's really important, and we spend a lot of time really talking about the why. We're really not just looking to talk about what we're doing. It's not just a data center migration, better, faster, cheaper hardware. Again, it's a culture change, a shift in thinking. And so we try to spend a lot of time thinking about reinforcing that this is an opportunity for us as an enterprise to start to align on common languages, common capabilities, common tooling, common ways to communicate with each other. And so that's where we're really looking to get a lot of the real benefit from this migration and this shift in our culture to help us build products faster and enable us to build things that we just couldn't do before. Maybe it wasn't possible, maybe we didn't have the tools. And as you start to talk about the why and engage with the organization, it's really important to spend a lot of time listening, engaging with individuals, engaging with different teams, because really you have to hear everybody out. Again, this is a large-scale company effort, and so you're going to be talking with a lot of different teams. It's really important. Make sure you hear everyone and they feel like they're being heard across all different departments. Again, engineering may be one of the easier ones, again, because some of this is exciting and there's fun technical problems that people like digging into, but at the same time, there's a lot of benefit for finance, better, easier traceability. There's benefit maybe to marketing. We can spin up things faster, certainly benefits to our product partners. So really important to focus and engage with all these different teams and look for different ways to engage with them as well. Whether that's different types of training, whether it's helping do kind of collaborative joint road mapping with all the different teams. Definitely a key to success there. And some of you who may have heard this rule in marketing called the Rule of 7, that rule basically states that typically you need to give a message to someone 7 times before they really hear it. And I think reinforcing the why behind this larger change and the benefits we're really seeking, that's kind of important to do here as well. Even if people, again, are excited about it, really understanding what it means and preparing and getting people to move more towards the better, faster, improved culture that you're seeking, you're going to have to say it a bunch of different times. You're going to have to say it a bunch of different ways as well. There's different stakeholders, different people with different needs, wants, and needs and wants change over time. So maybe you talk to someone 1 month, a month later, they might need some sort of different messaging. So Ken and I have joked a bit about, one of the best tools we have in our toolbox right now is just a whole lot of PowerPoint slides that are really just telling the story we're telling today in like 10 different ways. So just think about the ways you can kind of retell the story to get everyone engaged and excited about it. And lastly, it's really important as you focus on this change to work to make people feel like they have a lot of support. And one of the best ways you can really do that is to find a team within each different business unit and make sure that their first experience on the cloud, on AWS, is a really, really good success. And so success for a team is going to be different. And so a recommendation that we have is really work with a team to find multiple different opportunities that they can look to benefit from as they move up to AWS. For example, if you've got a team that maybe has a lot of expensive on-prem hardware and they'd benefit from auto-scaling, and at the same time maybe there's some red tape or some manual process that takes a lot of time, there's opportunity to automate. If you can help work with the team to find multiple different problems to solve in one effort, then it'll make more of a meaningful, impactful change to that organization. Maybe it'll make your engineers a little bit happier. Maybe it'll also make their stakeholders, business partners happier at the same time. Because if you get those teams to have a really good first successful experience, they're really the ones that are going to be the leaders in your organization going forward. When we talk about scale, we talk about large enterprises. A small group of individuals or passionate people can't be the ones that are running around getting everyone to continue to dive in and invest more. So, the more you can start to establish key leaders in your organization and make people happy, the better off you're going to be. And again, as this change evolves, it's really critical to just make communication and collaboration easy. Finding people that have run into similar problems, bumped into similar challenges, the more they're talking, the more they're collaborating, the more they're sharing their success stories, I think the faster the adoption will be and the more benefit you'll get.
So looking at that whole set of things we need to do to support the teams, we realized early on that creating an organization and that really focusing on engineering enablement was going to be crucial to our success. So when we say engineering enablement, what we're really talking about is making it easy to do the right thing. Again, we have patterns that we believe are the right way to do things. A lot of that's influenced by working directly with folks at AWS. We want to make those things obvious to teams. We want to provide them communication channels. We want to make it easy for them to get up and running. So we've tackled this in a number of ways. We have, like most of you probably do, an internal wiki. And on that internal wiki, we have a section called the Cloud GPS. We spent a lot of time thinking about how this should be structured. And what we did was we broke it down into 3 content areas. The first is titled Learn. Right? So this is where you go to learn, where you find your FAQs, links to events and seminars, training materials, both internal training, which we have put a significant amount of effort into, as well as external training supported by AWS, and also standards and practices. As we learn things, we try and contribute back. Right? As the teams make progress and they determine the best way to deploy a Beanstalk application, right? We want that to not have to be learned time and time again. So collecting all of that information into this one place has been really helpful, and it gives teams a place to go. We don't need to tell people where each individual document is. We tell them to go to this page. They can find what they're looking for. The second component is interaction. We are distributed across a wide geographical area. We have a lot of fairly large sites, but we also have development that's happening, very similar development happening across many of those sites. So we're trying to foster tech communities. An example, if you're interested in using Cloud Custodian, perhaps, right? We have a Slack channel for Cloud Custodian. So we're creating communities around the technologies that we use. Jenkins is another one for the build deploy pipelines. We have focused Slack channels. We also do open discussion forums, video chats, and then Q&As within Slack. We're really trying to help people understand this is not a corporate mandate that your team then needs to go execute on. This is a supported set of technologies that we're trying to help teams adopt so they can do better at their job. Finally, once you have the knowledge, you've got the interaction, you've been working with others, we still don't want people building things from the ground up, at least not building everything from the ground up. So we have the third section of this, which is consume. Right? So we have code repositories for common code, common infrastructure as code. We have a huge amount of blog posts of teams that have done the work, learned a lot, and then they've got code snippets, again, infrastructure as code. They're sharing out across the rest of the organization. And common tooling. We've built a bunch of common tools that I'll talk about in a few minutes that really help us to accelerate people, again, so we don't have 2,000 different engineers all solving the same problem time and time again. One of the things that's been really helpful to us is the account structure that we use, the AWS account structure. And this is something we've had in place for quite a while now. We have a single top-level master billing account. Every AWS account at Cox Automotive resides under that top-level account. There are no accounts that are tied to the credit card of Bob who just left the company, right? So everything we have is tied up to the master billing account. Finance deals with that. We also have tooling that can deal with that. All the accounts are created in a consistent manner so that the tooling can be reused across all the teams. We have what we call application level accounts. This is a little interesting depending on the team. I mentioned that we have teams that run large microservice based applications. We have teams that run large monoliths. So the question is, what's an application account? What goes into it? We really try and focus on a context or a domain from a domain-driven design perspective. A bounded context, the applications that need to talk to each other, that talk to each other most frequently, tend to be in the same account. That's not static. We've made mistakes. We've created 3 accounts when we should have had 1, and we've also created 1 when we should have had 3. We learn as we go, and the tooling that we have in place makes that a fairly inexpensive mistake to make. We can evolve away from those things. All the accounts come pre-provisioned with VPCs in the regions that are most frequently used, and then we have networking set up as well, so we don't have every team needing to go in and ask, do I run in US West 1 or do I run in US West 2? We have a strong opinion on that. It's pre-provisioned in that way. If a team needs a different answer, we can go in that direction, but at least they're starting off in the same place. So this account structure gives us a lot of ability to have common tooling across the organization. One of those tools is called AlKS. AlKS stands for Airlift Key Services, and you may have seen other similar tools at other talks in the past couple days. We built this between 2 and 3 years ago, and it's basically a federated identity management system. We log into AlKS with our corporate credentials, and then once we're logged in, we have complete access to all of the accounts that we're authorized to use. So depending on who you are, which team you're on, you might have 3 accounts, you might have 8 accounts. It's whatever you need to have access to do your job. This gives us the ability to not have developers running around with their own credentials. You've probably all heard the horror stories. We've all heard the horror stories. They've been drilled into our heads from the beginning. What happens when you have credentials and when you can make mistakes? And I've seen really, really smart people make those mistakes right through a series of unfortunate events. So this eliminates that for us. None of our developers have actual long-lived credentials. You log in, you can get your credentials either for an IAM session or for a full AWS admin session, and then you can log into the AWS console. You can also copy and paste those into your terminal and start working. To support more of the development workflow that most people are used to, though, we've also created some other tooling around AlKS. The first is a Terraform provider. So you're working within Terraform. We're really trying to get teams to think about infrastructure as code first. That's one of the real landing zone concepts that we have. The infrastructure is written as code from the get-go, trying to stay out of the console. Well, in order to provision an IAM role or a long-lived credential, that's not through the way that we're set up. We can't do that through the permissions that we have. So the AlKS Terraform provider allows us to do that. It applies a bunch of business rules on top. It limits the types of services that we can create roles for. And then that's just part of the team's workflow now. Similarly, we have a command line utility. So it's very easy. Open a terminal, execute the AlKS command line. You can get your session set up and then immediately start executing, whether it's SDK, CLI, whatever it is from that terminal session. In terms of support, like I mentioned, we use Slack. We have quite a few Slack channels, and it's really to foster community, right? We're trying to get people talking to each other. We're trying to prevent some of the typical workflow of, I have a question, I go to Google. Well, now we have a question, we go to the wiki. We have a question, we go to Slack. We have experts within the company, and how much better is it to go talk to someone that you might actually know instead of having to interpret what someone wrote 3 years ago that you found on Stack Overflow. Stack Overflow is still hugely useful, but we have a lot of that knowledge in-house now, and we try and use that, and we've structured our Slack channels to support that. I mentioned we have a lot of self-serve capabilities in terms of people being able to log in through AlKS. They can get long-lived keys. They can create the IAM roles that they need in a safe and secure manner. For anything that doesn't fall in that self-serve model, we use ServiceNow. And so you can go into ServiceNow. You can request a new account, add people to an account. The whole thing is pretty well set up and easy to navigate. People have a very small number of tools they need to use to work within this ecosystem, and it's really easy to get people up and running using those tools. One of the final big pieces we did from an enablement perspective is we want people to care about the cost of what they're building. And we found that the best way to do that is just to tell people the cost of what they're building. So we have that master billing account, and we are using Cloud Health, which is tied to the master billing account. And then with a series of perspectives in Cloud Health, we can drill down to the individual account level. Teams can see what their individual accounts are spending, what services they're spending with. What we found was we gave these tools to some teams, and very shortly thereafter, Cloud Health dashboards were showing up on people's information radiators, and they were getting alerts through PagerDuty when they went over certain spend limits. So we provided the tools, we showed people how to use them, they're integrating them, and now cost is just another thing that we talk about as a non-functional requirement in the same way that we talk about performance and availability.
So it's not just enablement tools and support tools that we've kind of rolled out and trying to standardize across the enterprise. We mentioned a little bit that we're really trying to provide a lot of common patterns, common architectures, code snippets to really get teams working faster, ramping up a little bit quicker, and able to share experiences a little bit better. I mentioned earlier common language, common tools. The more we're using the same sets of tooling, same platforms on top of AWS, the more we're starting to align and be able to share a little bit better. And so one of the initial things we came up with, someone in our organization coined the Beanstalk Hypothesis. That was the idea we had pretty early on that, especially when we were starting to evaluate a lot of these different platforms as a service, infrastructure as a service, there's a real balance between giving people a lot of raw control, but a lot of flexibility. We felt like Beanstalk would be a really good kind of in-between place that would support, at least 80% of the different workloads that we're running, be it large monolithic web applications, small little microservices, or different other kind of internal batch operations. Again, we know this might not be the right answer for everything, and we're not trying to limit that, but as we're trying to ramp on the organization, get everyone working and collaborating a little bit better, we thought this is a really great place for teams to start, and we've seen a lot of really good benefit. And really what we've learned is that it's actually working out pretty well for 80+% of our workload that we're starting to move up here. Certainly it doesn't have all the bells and whistles of some other tools, but we're always continuing to look to evaluate that. But it's worked out really well for us. And we've also had teams that have been using Beanstalk for a number of years that have a lot of really good success. So we already had kind of key SMEs in the organization and evangelists that we could go to help share experiences, failures, challenges. So a lot of really good benefit that we've found from Beanstalk.
So as I already mentioned, we're really treating infrastructure as code as a starting point. Amazon's giving us a set of technologies and services, but Amazon is giving us technologies and services that support a specific culture and a specific way of developing. And one major component of that culture is we're not manually configuring our infrastructure. We are not depending on heroes within the organization to configure it and know how it works and be there 3 weeks, 3 months, 3 years later. So infrastructure as code is a starting point for us. We have been using Terraform for probably about the last year and a half. We looked at CloudFormation. We have some teams that did use CloudFormation. We use some of the layers on top of CloudFormation, including PyPlates. But we've really settled up to this point on Terraform is a tool that supports the workflow, and developers really seem to enjoy working with. So all changes in any environment that is a production-related environment are done with Terraform. When I say production-related, if it's an application that is eventually going to production, we're calling that part of the production workflow. We are really trying to not just focus on the technology, but focus on how we build the application. If you go back to the 12-factor app, we have environment parity as a key component of that 12-factor application. Infrastructure as code gives us that environment parity. And then the third big technology and architecture component here is looking at the managed infrastructure services. So any of you that saw the keynote this morning, and we've got more now, and some of the ones that are up here are even better. So we believe that when they meet the needs of the individual application-specific use case, Amazon's managed services are the starting point for the tools that we use, whether it's databases, message queues, DNS, caches. We are focused on starting here and then finding out why that technology won't work for us. So we start with Dynamo, and if Dynamo is really not going to meet the needs, and there's really good legitimate technical reasons why we can't use Dynamo, then we'll look at something else, self-hosted on EC2, for example. But focusing on the managed services has allowed teams to get off the ground quickly and really avoid some of the discovery phase, right? When you apply that constraint and the team is working within that constraint, they can certainly raise a hand and say, this constraint is not appropriate for the use case that I have. That's fine. But when they have that constraint as a starting point, they can also start looking at some of the other problems they need to solve. And in many cases, choosing between running Dynamo or, say, MongoDB is not that interesting a problem. When it is interesting, it's super interesting, but most of the time, it's not.
All right, so next we want to go through a little bit of the learnings and experiences we've had in this journey over the past 1 to 2 years, especially. And so I'll give you a little bit of a preview and lessons learned and kind of the approach we took for or within AutoTrader to do some of our initial movement up to AWS. And so, again, I talked about finding an opportunity for a team to get multiple benefits, and we thought what better place for AutoTrader to get multiple benefits than moving our flagship web application up to AWS as kind of our first opportunity to cut our teeth. So a little bit of numbers about that. AutoTrader.com mostly has been running out of two different data centers, hundreds of hosts each. We're serving hundreds of millions of web requests a day, mostly people searching for cars. A little bit about our technology stack. We are primarily running Apache HTTP server on top of Node application servers and JBoss Wildfly. We also wanted to bring up a lot of our core dependencies up to AWS as well. We didn't want our website up, but all kind of the data stores back on the data center. And I think we mentioned earlier we're trying to do more of it, or we'll talk a little bit in a second about kind of approaches to move the data first. So we wanted our kind of primary dependencies up on AWS as well. So while we're not completely getting out of the data center yet, because this is a big enterprise with lots of different things feeding into AutoTrader.com, we at least wanted the core dependencies up with no hard reliance on our on-prem data centers. So Solar is the search engine we use to power most of AutoTrader.com. Pretty much just about any page is doing some sort of Solar search or more than one. We've also been an Oracle shop for a long time, so we have a number of different database tables powering AutoTrader.com. A lot of it kind of read-only. This is a very read-heavy web application. But there's a number of places we have different web transactions, inserts, updates as well. And another big challenge I wanted to call out here architecturally was we relied a lot on network storage. So we mounted up a lot of shared storage, and we used that for log aggregation. We used it for pushing content configuration even up to our web servers. And we knew that wasn't really a model we wanted to follow up into the cloud, so it's something we wanted to address here. So talking a little bit about kind of the approach that we took, really based on the tenets and the content we talked through a minute ago, we really tried to initially embrace this Beanstalk hypothesis. We had this pretty large, relatively monolithic web application I mentioned, our search engine, we had Jenkins on premise, we wanted that up there as well to do our build and deploys. And so really what we look to do is, again, try to do as much standardization of a platform as possible. And so our goal was really to get each one of these applications running on Beanstalk as a kind of a separate Beanstalk application. Since these are applications that have been on Red Hat virtual machines for a long time, what we decided to do was really leverage Docker to try to provide a similar container to our web application and our search engine that looked as much like our Red Hat virtual machines as possible. What this allowed us to do is basically deploy to our on-premise Red Hat VMs or up on AWS and Docker, and our web application wouldn't have to know or care. Docker would provide those dependencies for us. So really a lot of the work that we initially did was making our web application, our search engine, Jenkins, work in Docker. That was probably most of the work that we took. It was really doing things like eliminating any usage of host names. I mentioned shared storage. We had to re-architect a lot of that. Places where we were doing database inserts, we decided on the database side that it'd be pretty challenging to do multi-master replication, maybe a little bit easier next year. And so what we decided to do is really refactor our application and kind of rip out any of those writes and updates that are happening and make them independent microservices that we'd leave on-prem for kind of a second phase. So really this was one-way data up to the cloud where it can be self-contained and run all by itself. Another thing that we really did, I know this is pretty wordy, small text, but I'll talk through it a little bit. Really what we did was we tried to modernize our deployment and our build and deployment pipeline. Now that we had AWS at our disposal, it was an opportunity for us to really start to shift the way we build software, the way we ship software. And a lot of us, we were already using Jenkins, we were already doing all the same kind of pipeline-y stuff, but the kind of interesting thing that AWS really allowed us to do was start to rethink the way we treat environments. And so one of the things that we did that we found really successful is we have basically ephemeral environments for any of our pull requests, any of our branches. So at any given day, we're spinning up and creating dozens of environments that are only alive for the length of the testing phase. So we will create a brand new Beanstalk environment, run our security, our integration, functional tests against it. Maybe we'll leave it up and running for the duration of the pull request if we want to do some sort of user acceptance testing with our business stakeholders. But basically, whenever we merge down that pull request, the environment goes away, we're moving forward. So we found a lot of really good benefit here. And again, we talked about kind of standardizing on infrastructure as code. We started to replicate a lot of our infrastructure, or manage all of our infrastructure configuration as new GitHub repositories that we're then starting to build and bake into the same deployment pipeline. The approach we took to actually roll this out, get some traffic on it, we tried to, or we're big into A/B testing and experimentation, and so like anything else, we didn't want to do some big bang deployment, and certainly that wouldn't be a good idea for anybody, certainly not a large web application like this. And so really what we tried to do was we leveraged our content delivery network, Akamai, to treat AWS as an extra data center. It was a really easy configuration for us to make. It also allowed all the benefits that we get around data center failover, in case something we did on AWS initially wasn't quite right, wasn't working quite well, provided a really good safety net for us to operate. I mentioned earlier we tried to treat Docker to look just like our Red Hat VMs as much as possible. So our web application was always the same web application. We never had to fork it or manage it. Everything was either feature flagged, or the container was really just providing all the dependencies necessary. The application didn't know or didn't care where it was running. We found a lot of value to this approach. We've been doing on-off testing for the past several months. We're running 100% on AWS right now, but even this morning we were only running 50-50 on-prem and up in AWS because we're still doing a lot to understand kind of the business metric impact, the performance impact of this migration, this change. And we didn't want to rush it, and we want to spend a whole lot of time really fine-tuning. We found a lot of opportunity to use new EC2 instances, to fine-tune our application and work better on AWS. So we've been able to keep this kind of structure in place for a while to where we would really fine-tune, really be happy, really become happy with the performance from a technical and a business perspective. And I'll kind of close out by saying we found a lot of really good success here, a lot of initial hypotheses and kind of approach that we took worked really well. We've seen massive cost savings from our infrastructure. We haven't realized it yet, but we're starting to project it and get a feel for it. And just to kind of give you a hint of why, our on-prem data centers are really sized for our peak traffic, and for us that's the Super Bowl, which only comes once a year. The rest of the year we're not creating quite as much traffic, and since we like high availability, we like reliability, we're really sized 2x for that peak traffic. But on AWS we have really good auto-scaling rules in place now, so we're able to get nowhere close to that peak except when we need it. And again, you can imagine all the non-production savings that we're also getting as well, since we can just spin everything down automatically.
All right, so onto the Dealer.com side of things. So like I said earlier, Dealer.com is a provider of digital marketing for the automotive industry, and a major component of that is the Dealer.com website platform. So the Dealer.com website platform hosts somewhere in the vicinity of 15,000 dealership websites. If you've shopped for a car online and gone to the dealership website in the last, whenever you've been shopping for a car, you've probably been on a DDC, Dealer.com property. We have approximately 52 million unique visitors per month across all those sites. and we take in about 200,000 leads per day. Some of those leads come directly from the website platform. Some of them come from call tracking providers that we partner with. But the leads are kind of a core component, right? We have a saying that we don't lose leads. When you lose leads, things are bad. Dealerships want those leads. They need those leads. That's how you communicate. You go to the dealership website, you schedule a test drive, you make a request for more information about a vehicle, you make a service appointment. Those leads are the lifeline for the consumer to the dealership. And when that's not working, we're not having a good day. Bad things happen. So the leads platform is a fairly old component of our system. It's in the 10 to 12, maybe older, 10 to 12-year-old variety. So we focused on this as a component that we wanted to move to AWS initially. And one of the reasons we did that is we had to integrate a new source of leads, a new call tracking provider. And what that is when you call the number on the dealership website, that isn't actually the dealership's phone number. That goes to some other provider that will route you to the dealership, but then all of the metadata about that phone call is preserved, right? And that comes into the dealership as a lead. So we had to do one of these new integrations, and we said this is a good opportunity to really put some of these hypotheses to work, just like Justin mentioned at AutoTrader. So the legacy platform consisted of a number of inbound lead sources. We get some leads coming in from OEMs, from the manufacturers. We get some leads coming in through call tracking providers making HTTPS calls into our services. We have some leads actually coming over email. They'll send us email for each lead. And then obviously we have the website platform, and anything you do, any way you interact on that website, that's also coming into the system as a lead. We're using RabbitMQ on-prem as our messaging system. Eventually, all those leads come into a JVM, a Java application, that is doing all the processing and persistence. And then we have a set of applications that the dealership users can use to view the leads and communicate, call people, respond via email. So we started with the Beanstalk Hypothesis and favoring managed services. And we started off by adding a new endpoint. Right? So the new endpoint was going to be where the leads came into for this one call tracking provider. What we quickly got to was that we were fairly quickly successful doing that, and then we said, well, let's just move all the ingest. We had originally said, we'll take it end to end. We'll take one type of lead coming into the system, and the processing of that lead and the persistence, but we quickly realized we'd gain a ton of benefit by just taking all of the ingest endpoints and putting them into AWS. We gained significantly faster development velocity. We also gained a lot better disaster recovery capabilities. So within the span of about 6 months, we had moved 100% of our lead ingest into AWS. That's HTTPS endpoints, that's messaging endpoints from our internal applications, and it's also email endpoints. The email was an interesting one. We talked about change management and how working with people to change the way they think about things. The first iteration of email, the inbound email leads was we'll stand up some EC2 servers and put mail transport agents on them. And then we said, well, why don't we use SES? And we did, and we eliminated a dozen-ish virtual machines, and a couple of our systems engineers had a much better life after that. They get to work on more interesting things. So really taking those starting points of using the managed services, using Beanstalk, and finding out that there was a pretty good starting point, and it really did work well for us. So today, 100% of the ingest of those lead sources is coming in through HTTPS endpoints or SES, coming into Beanstalk applications, immediately persisted into S3. So no matter what happens after that point, applications are down, processing fails, we can always go back and reprocess. Lost leads are largely a remnant of the past. And we're now working on taking the processing itself and moving that up into AWS, and we're able to do this in pieces. So we've got the ingest, processing is slowly moving up, and we'll continue to either rebuild those applications or lift and shift those applications over the course of the next probably 6 months or so. So as we've gone through this, we've identified a number of patterns that are important to us. And one of the big things for us has been hybrid architecture, hybrid being on-prem and cloud. We're not going to, even within Dealer.com, just one of the larger companies, but one of 27 brands within Cox Auto, we're not going to be able to lift and shift the entire platform, the entire set of applications in a short amount of time. So we need to live in a world where we have applications that run on-prem and in the cloud. We live in a world where we have many AWS accounts. And if you think of the networking involved, the number of VPNs that we would be creating, it becomes unmanageable at some point. So we really realized early on that we need to think of ways to make it easier for our on-prem applications to work with our cloud-based applications as we go through this migration process. That includes secure and reliable transport, it includes authentication and authorization, and it includes acceptable latency. So one of the first patterns that we have really embraced, and maybe it seems obvious eventually, but using IAM and the SDKs to integrate directly with AWS services from the data centers. This took a little bit of getting used to for some people because there was a perception that using IAM credentials, long-lived keys, is an anti-pattern. And there's plenty of cases where that is true. But for these applications that run in the data center and that need to access cloud services, we found that treating the keys as any other secret, handling those keys responsibly, allowed us to integrate directly with the SDKs and eliminate a large number of use cases that we didn't really want to have to support. What it also came down to was that if we had stood up HTTPS-based services, a RESTful service, for instance, for communication between on-prem and the cloud, we'd still be handling authentication and authorization, and those keys are just as critical as the IAM keys. So a lot of the applications we have today are hitting things like SQS, S3, in some cases Dynamo, from on-prem, and they're using that as a stepping stone to move those applications into AWS. The second pattern that we've identified, we're just calling cloud-ready applications. Basically building applications that are destined for the cloud, but for some short amount of time do need to live on-prem until all the components of that system are ready to move. So I mentioned earlier that this isn't just about the technology that Amazon gives us, it's about the way that we build the applications. So building those applications along the lines of the 12-factor app on-prem, and as Justin mentioned, using Docker and AutoTrader, allows us to then have that flexibility so that when we have enough of a body of work that we can move it up to the cloud, we don't need to re-architect what we have, right? So we're building applications using 12-factor patterns. We're building those applications using the AWS SDKs so that they're working with SQS and S3 and Dynamo right out of the box instead of doing a two-step or even three-step process where we have to put them in the cloud and then migrate them to use cloud services. One other technology that's been hugely helpful here is Netflix Hollow, a caching solution that we've been using quite a bit lately for a number of the applications that are going to live in the cloud, but for the foreseeable future, 3-month, 6-month horizon, are still running in the data center. They're able to use Netflix Hollow. They are able to deal with eventually consistent data. And once we move those applications to AWS, or in some cases the same application is running in both places today, we don't have that fork that we need to do. Closely related to consuming services from on-prem is the mind shift of using asynchronous services. Many times, the way that we have applications integrating within the data center, it's a lot of service-to-service communication. We're finding that while that's appropriate for a lot of use cases, we often overuse it. It's a hammer, everything else is a nail. Looking at asynchronous integration allows us to eliminate a whole set of failure cases in our on-prem to cloud architectures. So when we can rely on eventual processing because something is in SQS or it's in Kinesis or it's been pushed to S3 and it will be processed at some later point in time, you remove that temporal coupling. You no longer care if one of the services is down or the VPN has gone offline. The service, when it comes back up, will continue processing. Your data is not lost. So this is another big thing that we're focused on in terms of the starting point for building applications is to use asynchronous integration, use the AWS services that support that asynchronous integration, and then when the application is ready to move to the cloud, it's literally a lift and shift for that application. And finally, we have a concept that we've been looking at Dealer.com of moving the storage first. So we have many applications that consume the same data, whether it's blob store data that you might have in S3, file system data, or databases. What we're finding is that by moving the data to the cloud first, we're able to then move individual components. And what we inevitably find is we have a source of data, say a file system, that a single application uses. And we get all ready to move that application and its data to the cloud. But then we find out that over the last dozen years, people have built 100 other small command line utilities or other operational tools that also need that data. Well, now we can't just simply move it. Amazon Storage Gateway has been a huge help in that regard. Storage Gateway did not look like the type of technology we would have at first adopted as a SaaS-based business, right? We're not moving file systems for shared file systems, shared file servers. But we do have NFS running on-prem. We have applications that over the years have kind of bound themselves to that. Storage Gateway gives us the ability to preserve that model today while moving the storage to AWS and then start moving the other components, or hopefully retiring some of those other components. Similarly with DMS, the database migration service, or using direct access to Dynamo. So anything we can do to move the data into the cloud first, support a eventually consistent model, use asynchronous integration, is really helping us get applications moved in a more flexible manner. It's allowing us to not solve some really hard problems. The hard problems are hard, and so by not solving them, we're moving faster, and we're able to have a lot more flexibility in terms of the types of solutions that we can build.
So in wrapping up, just want to talk a little bit about kind of the next steps that we're looking to do across the enterprise. We mentioned a little bit about what we've done, a lot of learning, a lot of good lessons learned. We're starting to collaborate a lot more. So going into next year, we're really just looking to accelerate and continue that, getting a lot of the teams some initial experience on AWS, keep people talking more, sharing code snippets, building out more patterns and documentation to help us all ramp up faster, ramp up smoother. And after that, we're expecting to begin to really realize a lot of the benefits, both on the hard cost savings as well as our ability to really build unique products that leverage a lot of the different skills and cultures across our larger enterprise. So with that, I think we have a couple minutes left. We're happy to take some questions up here. And if you want to talk to us or contact us after the event, feel free to email us or hit up Kevin on Twitter.
Yep,
Any questions?
In the back. Yep, if I heard the question, you're asking about the initial roadmap and timelines for some of what we've done? Yeah, so we've been, like I said, it's been about 2 years now. And just to go back to that previous slide, 2016 was the inception, really starting to look at this seriously, looking at it from a financial perspective, looking at the technical realities of doing this. A lot of learning in 2017. I think in 2017 we had a small number, less than a half dozen platforms across the company that were actively engaged in getting there. 2017, well, as we finish the year, we've got AutoTrader pretty close to just being able to go, full bore on AWS. You said you're doing the 100% today. A lot of the Dealer.com platforms are up there and running. Well, a small number of the Dealer.com platforms are running there today. We have a number of others in 2018. So out of those 45 data centers, we have at least one that we are scheduling the work to be able to close in 2018. Looking at 2019, we're looking at shutting down a fair number of additional data centers. I'm probably going to get the number wrong, but I think we have at least another probably 4 or 5 data centers within 2019 that we'll be able to vacate. There is going to be a long tail here, and part of what we're doing, it's not just the cloud migration aspect. We are looking at data center consolidation, whether it's in Amazon or somewhere else. We don't want to be running 45 data centers. So there is a consolidation effort for, if you're familiar with the 6 R's or the 7 R's of cloud migration, rehost, retain, retire. There are applications that we will be retaining in a different data center as we consolidate and build out infrastructure in that data center. We have, Justin mentioned some AS400 workloads. We have some workloads that are using technologies that we really don't want to bring with us to the cloud. So we do have a strategy for handling those as well. But we're on about, from here on out, I'd say we're about a 3-year timeline to really get the vast majority of these applications out of the on-prem data centers and into AWS, and then consolidate whatever doesn't make that move.
Any other questions? Yep. Straight up what? Sorry.
Lift and shift.
Oh, lift and shifts? we have a variety of teams taking different approaches. The AutoTrader case study I gave you is probably the closest one that I'm aware of that's more of a lift and shift. I mentioned we did a good bit of refactoring. A lot of that was just kind of re-architecting to do things like event out logs and stream out data, things that we did on premise many months before we actually moved to the cloud. We talked about kind of cloud ready. That was one where we kind of called it a lift and shift, but it was kind of a, talking about the 7 R's, kind of a combination of re-platform, re-architect, refactor. But we found a lot of success in that. It was a big, complicated, high dependency web application. We tried to just remove and add layers between all these dependencies, and then really use Docker to just kind of bundle up the rest of it. So in the end, we were able to pretty easily kind of just, once we had it running in Docker, it was by the end of the afternoon, it's up and running on Beanstalk, at least from a functional testing perspective.
We've got some workloads in 2018 that we're definitely targeting as a lift and shift. So a year from now, hopefully we have shut down one data center, primarily 3 doing lift and shift. Certainly we want to take advantage of cloud technologies and the patterns and the architecture that goes along with it. There's also a lot to be said for getting the application running in AWS and then iterating from there. The iteration is so much easier once you're running there. It's trying to find that sweet spot between how much technical debt are we willing to take along with us, how much interconnectedness do these applications have. So for systems that can be lifted and shifted, we're definitely looking at that as the starting point. There's some folks in the room that would be happy to talk to you about that after.
And we're certainly evaluating. We have a big enterprise, and every application is going to be contextual. I don't think there's, we have some high-level decision trees to help teams figure out the right approach, but everything's contextual. And we are looking at other options where we're just trying to, burst out VMs or take some of our existing on-prem virtual machines and just kind of get them hosted and running up on AWS. So I imagine we'll take kind of a combination of all the approaches, but we try to at least get things a little bit more cloud native whenever we can. So that's why we haven't entertained that one as much yet.
Back.
How are you approaching, or how have you approached, I suppose, your discovery and mapping of your existing environment to plan those migrations, and then how do you continue to do that once you migrate?
Yeah, we have a whole team that is dedicated to not just the AWS migration effort, but the data center consolidation effort. So they've been building out those plans and those inventories of applications. They've been using some tooling. We use some, I can't recall the name off the top of my head, but we did use some tooling to map the data center, determine what we had, at least from a physical asset, or in some cases virtual asset perspective, and then look at what, how that maps in to AWS if we, assuming if we lifted and shifted the whole thing, which we're not, but as a starting point, it gave us some idea of the footprint. That team is, managing, kind of working with all of the various business units and on a monthly cadence, reviewing where they are with the progress they've made, what's next for them, are they online to hit their targets to retire this application, that application. We're really trying to think of, the word application is pretty heavily loaded. Again, I said for someone that runs a monolith, an application makes sense. For someone that runs a microservice or a service-based architecture, what's an application? We're using the word platform to denote a set of applications, a set of artifacts that provide a business capability. So we're really looking at these platforms. So within Dealer.com, we've got an advertising platform, a website platform, a leads platform. And that allows us to not get caught up in the individual application, individual data source. We're able to look at it at a higher level. And then when we get closer, we certainly dig down into the number of VMs, the data sources, the file storage, et cetera.
Yes?
Given the amount of traffic on your websites, before you went live at AWS, did you load test before you turned it on?
Absolutely. We did a lot of load testing. Most of it was in-house, like JMeter scripts. We actually wrote some custom tools and evaluated others to do kind of leverage ECS and some of these other tools to kind of scale out JMeter scripts. So we did a lot of, for AutoTrader at least, a lot of, in-house capacity planning. That's how we did a lot of our testing to determine initial workloads and EC2 instance types. So latency is very important to us. So we were focused initially mostly on getting really good latency. And once we did that, we tried to then we landed in a place that had very similar CPUs and infrastructure to what we had on premise. So when we first started trickling some traffic in, we would just send like 0.5%, 1% of our traffic over to AWS and just way over provision, and then watch it, and then slowly work on bringing down our auto scaling rules. And we did find that it's so much easier to do things like test CPU types on AWS. So that's why we spent several months and continue to spend some time, just putting some amount of traffic on AWS to allow us to just try all different types of network settings, Docker, EC2 tuning settings. So, but yeah, we definitely did a whole lot of performance, capacity, load, latency tests ahead of time. Yes?
You had a slide you mentioned that you have an organizational structure for your accounts, your non-prod stuff that you're running.
Yes.
Do you have situations where you have metadata or data that's shared between the environments? How do you handle that?
Yeah, so for those application accounts, every application account or bounded context account will have two actual accounts. We talk about it as like the website platform account, but it's actually two. It's prod and non-prod. And they're provisioned identically. We have the same like restrictions, security restrictions on both of them. The only thing that really crosses over is the build and deploy. So I'm not going to say this is true of all teams, but most teams are running all their build deploy out of their non-production environment. And non-production isn't just the environment. Non-production will run QA, beta, dev, staging, all your ephemerals, right, everything else. It also runs your CI/CD pipelines. So the only thing we ended up doing was there is a IAM relationship between that account that allows it to publish out to the production account, and the production account is only the production application. But using Terraform, most of that's handled through the infrastructure as code, and then you've got just the things that are truly different between them are handled individually.
Yeah, everywhere else we just try to set up, trusted, REST endpoints that just goes out to the public internet and treat them as kind of truly contained teams. And as we try to shift our culture to be a little bit more autonomous, a little bit more independent, and treat everything as a shared service, we try not to set up too much. We do stream a lot of data out. All these accounts, we talked about Cloud Health. All of our cost reporting goes into one place. We send a lot of information into Splunk as well. So we can do kind of aggregated reporting, monitoring across all of the accounts as well, which we found really valuable. Any other questions? Yes?
For teams like server teams, on-site application servers, things like that, how do you guys get them to be on board? They're figuring say, oh, we should do everything with the cloud. What about our cloud?
So how do we get our on-prem teams, operations teams that are managing a lot of infrastructure excited and helpful? Yeah, I think that's certainly a challenge. I think what we try to focus on is there's a lot of the things, it's the typical automation robot problem. There's better problems to be solved. We're not looking to do headcount reductions. We're looking to find those people that are skilled employees, have context, retrain them, get them excited, get them focused more on some of the business problems. So a lot of our teams where we are a little bit more, operational and dev, we're looking to try to blend them, get those operations guys a little bit closer to the development teams, get them to teach and understand and help build better automation around, performance management, security testing. There's so much work to be done. So it's a message that's delicate, and we certainly continue to work on that. But for the whole, it's been pretty beneficial. I think a lot of people see the excitement, and there's opportunity for anyone that's excited here because there's a lot of work to be done, and this just opens up the world of possibilities. So
it's really an extension of what we were trying to do in many cases anyways, which was really push forward the DevOps culture, right? And break down some of those walls. So that was something we were trying to do in a lot of different places, and this just makes it a lot more real. So it's certainly delicate. There's been a lot of difficult conversations. People are concerned. I come from the development background. I look at the folks who are on the production engineering and systems engineering teams as people who have a ton of experience and a great mindset for operations. And we'd be foolish to think we don't need that going forward, right? So the skill set or the actual, the day-to-day might change, but the previous experience and the knowledge and the passion is still very much required.
We've got time for probably one more question. If anybody has something? All right, if not, we'll be hanging out if you want to chat with us a little bit more, and definitely feel free to email us.
Yep, thank you very much.